Well, it's time to get your pom-poms out and celebrate because we are starting our very last chapter, and it's a quick one. It's an intense 4-day chapter. We're going to hit some statistics really hard here, and no better way than to get out probably the biggest definition here. And statistics is concerned with the collection and analysis of data. And that, in its simplest form, is what statistics is all about. Now, there's a lot of different ways to collect data. There's a lot of different ways to analyze data. And there are strengths and weaknesses to all of these strategies depending on the objectives of your research. And so that's what we're going to look at throughout the next 4 days. Well, the three big buzzwords we're going to look at, the three different types of statistical studies. Number one is a survey. And you're going to see on the next slide, kind of a questionnaire or taking a poll is a good example of a survey. Number two is an experimental study. Now, as far as our lingo goes, a lot of times they'll call that a controlled experiment, and so that's the other name they'll give to that we'll see a lot on the test. And then the last one's just an observational study, and just without me really teaching you a whole lot of specific things about these three studies, you could probably, infer or make some logical guesses as to the differences on these three studies and how they operate, but nonetheless, we'll go into each of them very deeply. Okay, before you have a heart attack here, we're not going to copy down everything you see on this page. I'm just going to try to pick out some of the most important stuff, and anything I underline in blue I expect to see in your notebook tomorrow. So first sentence here, statistical surveys are used to collect quantitative information from a specific population. That's important. The biggest word there is quantitative. Quantitative information is information pertaining to numbers, like how many people prefer whipped cream on their pumpkin pie, for instance. I want to know the number of people that prefer that whipped cream. Or I could say, what's the number of people that use a Colgate brand toothpaste in the morning? That's a quantitative information example. What are the advantages of a survey? Well, they're very easy to administer and in a variety of forms. And they're also efficient for collecting data from a large population. So if you wanted to survey, like 1,000 people, it'd probably be a lot easier to do a survey than the other two types of studies you'll see later. Disadvantages are that they're very dependent upon the respondent's honesty. You're kind of on the honor system. And the other one that's not necessarily on this list is it's very hard to create a survey that is unbiased. So I'm going to put biased here as a disadvantage. It's harder than you think. Speaking of that, this last sentence here, when a sample is not random, a bias is introduced which may influence the study in favor of one outcome over other outcomes. And that's what we're going to have to be very, very careful of when we create our surveys. All right, we're going to have to bite the bullet and write down quite a bit here. So when I go too fast, just hit that pause button, rewind it, replay it, whatever you got to do so that you get everything in your notebook, because this is our one shot at this topic. In an experimental study, the researcher takes measurements of the sample population. And then here's the key. The researcher then manipulates the sample population. Okay, I can't underline that little blue part enough in some manner. After the manipulation, the researcher remeasures or resurveys using the same procedures to determine if the manipulation possibly changed the measurements, okay? I know that, without any examples in front of you, that's a very weird one. We're going to get to one here, an example that's going to clear that right up. And and we mentioned this earlier, a lot of times they'll call this a controlled experiment. That's the lingo that New York State's going to use on the Regents exam. During a controlled experiment, the researcher will separate the sample population into groups. We're going to separate the sample population into groups. One group being established as the control group. All groups will be manipulated in some manner except for the control group, which will remain the same. So here's a good example. It says a group of students is interested in knowing if the number of times you can sink a basketball is related to the color of the basketball. Kind of a funny question, but maybe there's something to it, right? So the students shoot a series of baskets and record their success using a regulation-colored basketball. And then here's the kicker. Here's where the manipulation takes place, right here. Here's what makes it an experimental study. They then switch, that's a key word, to a blue-colored basketball and shoot the same, remember it's got to be the same procedures that second time through, series of baskets, and a statistical analysis is performed. Okay, here's our third and final type of study, and it's an observational study. And basically, you're sitting back in your lawn chair and just watching this group do whatever they do. You are not manipulating the experiment in any way, shape, or form. You're not intervening or interfering in any way, shape, or form. So in an observational study, the sample population right here being studied is measured or surveyed as it is. Again, those three little words in blue are the most important. The researcher does not influence, not influence the population in any way, shape, or form. There is no experimental manipulation. And then this example down here is very important, or a good example. It says a group of students is interested in knowing if there is a correlation between attending an SAT prep class and the scores achieved on that class. Seems logical, right? Hopefully. The students use a survey to collect their data from both students who took the SAT prep class and those who did not take the SAT prep class. So there's no interference. You're just recording the data and you're going from there. Okay, in the next 5 slides, I've got some real good examples of some Regents questions, and some of you are going to really like this topic because there's not a lot of pencil and paper work. You just kind of read the question, you think about it a little bit, and hopefully develop a strong answer. But here we go. A yearbook staff has designed a survey to learn student opinions on how the yearbook could be improved. If they want to distribute a survey to 100 students and obtain the most reliable data, okay? Reliable data means that we are unbiased. All right, unbiased. I can't say that enough. So here's the deal. Should we interview or survey every third student sent to the office? Probably not a good idea because that's kind of what we call a skewed population. You know, those are the renegades, the troublemakers, so to speak, and they probably have a little bit of a biased take on things. Should we interview every third student that enters the library? Again, kind of a skewed population. It's a certain type of student that goes to the library. Number 3, should we interview or survey every third student who enters the gym for a basketball game? Again, that's a very specific population, kind of a skewed group. And the 4th one says every third student arriving at school in the morning. And that's your winner. Ding, ding, ding. That's your winner. That's your most unbiased group of students. All right, a survey completed at a large university asked 2,000 students. Now, again, that's an advantage of a survey is whenever you have a large number of students. They estimate the average number of hours they spend studying each week. Every 10th student entering the library was surveyed. The data showed that the average number of hours that students spent studying was 15.7 per week. Which characteristic of the survey could create a bias in the results? Okay, number 1, the size. I don't have any problem with the size of the sample or the size of the population. 2,000 students is a very large number, which makes it reliable and unbiased. You know, if they only surveyed like 5 people, then that's a very low number, and I would say that the size created a bias. But I don't have any problem with this one. The method of analyzing the data, no, nothing wrong with a survey, and that's what I would refer to as the method. Nothing wrong with a survey, but I do have a problem with number 4 here. The method of choosing the students who were surveyed. If you want to know the average number of hours the students spent studying, you shouldn't interview just the ones entering the library. Maybe maybe interview the ones that go through the cafeteria because that's a pretty random, unbiased group of people. All right, which task is not a component of an observational study? Now, remember, observational means you're sitting back in your lawn chair and you are simply observing a certain event take place. Okay, number 1, the researcher decides who will make up the sample. Number 2, the researcher analyzes the data received from the sample. Now, those are very normal. You got to decide who makes up the study. You got to analyze the data. Those are very good things. Number 3, the researcher gathers data from the sample using surveys or taking measurements. That's very legit. Like if you look at the example we gave you earlier, we talked about giving a survey to asking people how many hours you went to the SAT prep class or whether you didn't go to the SAT prep class. Those are taking measurements. Number 4 here, I got a problem with this one. The researcher divides, that's a key word there, the sample into 2 groups, one acting as a control group. That's not an observational study, that's what we call an experimental study. So this one right here is not observational. Okay, a doctor wants to test the effectiveness of a new drug on her patients. She separates, okay? That's it divides her sample of patients into 2 groups, and and administers the drug to only one of the groups. She then compares the results. Which type of study best describes the situation? As soon as you saw the word separate into two groups, you instantly knew that it was an experimental study, also known as a controlled experiment. This one I want you to read on your own. You've got a couple of choices down here towards the bottom, whether it was a controlled experiment, an observation, or a survey, and I want you to share. Make sure you justify your response briefly. It doesn't have to be a paragraph, but we should write one very complete sentence describing why you chose your answer, and I will check your thoughts in your notebook tomorrow. So this is the second half of our video. We're going to kind of change and move on to basically a second set of notes here. Our first half we talked about the basic definition of statistics and the 3 different types of studies, and we looked at 5 really good past Regents exam questions. Now we're going to move on and we're going to kind of graduate and talk about measures of central tendency. This is going to be a lot of review from like second grade basically. We're going to talk about mean, median, and mode right off the bat. Mean is going to be the average. I think we're all very comfortable finding the average for a set of data. If you take 5 tests and you want to know the average, you simply add the 5 scores together and divide by 5. So notationally speaking, it might be t sub 1 plus t sub 2 plus t sub 3 plus t sub 4 plus t sub 5. And after you add those 5 test scores together, you simply divide by 5, or the number of tests. The next popular number is the median. The median is, of course, the middle number. Does it feel like you're back in second grade? And basically, you're going to write the numbers in order from smallest to biggest. And the middle number, once you organize them, is your median. If you have an even number of data, then you would take those middle 2 and average them together for a median of 3.5. And then, of course, there's mode, and that's the number that shows up the most often. And so I don't think we have to explain those too much more, but here's a really good, what I've pulled out is a really good possible Regents question with a little extra twist to it. So here it goes. A survey was taken in biology class regarding the number of siblings that each student has. The table shows the class data with the frequency of responses. So here's the deal. How many kids in your class had one sibling? Well, there was 5 different kids in this biology class that had just one sibling. And then there was K number of students that had 2 siblings. There was 8 students in the class that had 3 siblings, and so on and so on. Here's the trick. If you knew ahead of time that the mean was going to be 2.5, can you find the value of K? Well, there's kind of a long way and there's kind of a short way to deal with this question. The long way, I'll show you really quick, is, here we go, I'm going to add the number 1 to itself 5 times. And then here's where it gets a little tricky. Well, you know what? Let's skip the 2 and the K for a little bit. We would then add the number 3 to itself 8 times. All right? Do you see how tedious this is getting already? And I'm only getting started. And then I would add the number 4 to itself 4 times. And then I would just do 1 plus 5 and so forth. But what we're going to do is we're going to kind of shorten that up. I'm going to say, instead of going 1 plus 1 plus 1 plus 1 plus 1, let's just say 5 times 1 plus 3 times 8 plus 4 times 4 plus 1 times 5. And then last but not least, let's say K times 2. Now we need to divide that up by the total number of students in the class. And it looks like there's the frequency here tells you the number of kids in the class. So it's 5 plus K plus 8 plus 4 plus 1. 5 plus K. And if you want to add those numbers together in your head, you're more than welcome. I'm just trying to be very deliberate. Now what we need to do, and I need to slide this over and make just a little bit of room, we need to set the whole thing equal to the mean, which is 2.5. Whoops, I didn't quite fit it in there, did I? Let's move this over just a little bit more. Okay, and then basically now that we have this equation written, we're going to solve for K. We're going to clean up the numerator and the denominator a little bit. So basically from this point forward, we just have a lot of algebra here. So it's like 5 plus 24 plus 16 plus 5 plus 2K. If I combine like terms in the numerator, I ended up with 50 and then plus 2K. On the bottom, I combined like terms and I ended up with 18 plus K, and of course that's equal to the mean that they said I had to have of 2.5. Let's go ahead and put that over 1 and cross multiply. 18 times 2.5 is going to be 45, I believe, plus 2.5k equals 50 plus 2k. Go ahead and solve for k now. I'm going to subtract 2k over to this side. That's going to give me 0.5k. Subtract the 45 there and get a 5. Divide both sides by 0.5. And my final answer is going to be 10. So there was a frequency of 10. There was 10 different students in that class who had 2 siblings. Let's try that style of question again. All right, now that last question was a very tough one. Historically, it's been one of the harder ones on the exam. So if you need to replay it, rewatch it again, go ahead. Now what I want you to do is I want you to take that same process and I want you to apply it to virtually the same kind of question here where we solve for k. They told you ahead of time that the mean on the quiz scores was 18. Okay, and I want you to find k. K represents the number of students in the class that scored a 19 on that quiz. I want to figure out how many kids had to score a 19 in order for the average to truly turn out to be 18. Follow the similar process, and I'm going to be looking for your work and your answer tomorrow in your notebook to see how well, kind of give me some feedback on how well we understood it, okay? All right, we're almost done. I know we're coming down the home stretch. We're covering a lot of things tonight, but we're going to have to in order to get this unit done in the 4 days we have this week. Of course, the third quarter ends here coming up shortly. The second quartile is, whoops, forgot to grab my pen. The second quartile is basically another word for median. Organize your data from smallest to biggest. Find the middle, and that's your median. It's also called the 50th percentile. If you remember doing box and whiskers back in the day, box and whisker plots, hopefully this terminology sounds familiar to you. 50th percentile now, I think this will make a lot of sense. It doesn't mean that you got 50% correct. What it means is you outperformed 50% of the competition, okay? So, on your test, if I said you scored at the 50th percentile, your grade might have been an 80. What it means, though, it just means you outscored 50% of the peers in your class. Now, the first quartile is going to be, catch this, it's the median of the lower half. When I say lower half, that's all the data that was less than the original median. That's the lower half. And so if you took that lower half and then cut that in, half again, basically, this would be the middle of the lower half. The third quartile, I bet you can guess this, following a similar pattern, it's going to be the median of the upper half of data. All right. And the interquartile range is basically the third quartile minus the first quartile. And I'm going to show you on your calculator here before the night's over how to get those quartiles on your calculator. It's kind of a quick way to cheat. All right, we're ready to do some hardcore calculator work. So wherever your calculator is, go grab it, hit the pause button, run up to your room, run out to the car, wherever you got to go. You got to personally go through the process yourself. Otherwise, it's going to be very confusing tomorrow in class. So here's the deal. The table displays the frequency of scores on a 10-point quiz. Sounds like our, one of our quizzes we might take, and it says find the median of the scores, or the middle score. So it says one student in the class had a score of 5, 5 students had a score of 6, 8 different students had a score of 7, 14 different students had a score of 8, etc., etc. So here's the deal. I'm going to be very detailed. We're going to go through the calculator nice and slow, make sure everybody gets it. The first thing I need you to do is find the stat button. It's right here, kind of towards the top middle column, just below the delete button. Once you hit that stat button, it'll take you to a screen that looks like this. And we are on the edit menu, and I want you to hit choice number 1, edit. Once you hit the edit button, it takes you to this screen here where we're going to enter the data. Okay, the scores go into list number 1. If you already have numbers in that list, which you will at some point eventually if you don't already, I need you to move the cursor so that it's highlighting the L1. And once you're highlighting, hit the button for clear and then hit enter. If you hit delete instead of enter, bad things are going to happen, and just bring your calculator to me tomorrow and we'll fix it up. Okay? Once you enter, then you can type in the 5 and the 6 and the 7, 8, 9, 10, so on. Then highlight the L2, again hit clear and then enter, then type in your frequencies. Notice your frequencies always go in L2 every single time that we do this process. You're going to do it a lot. Okay, once you get the data entered, I need you to hit the stat button again and go back to that menu we were at earlier, except this time we're not going to do any more editing. I need you to go over to the calc menu. Use your cursor, use the right arrow, go to the calc. Once you get to the calc menu, it should look like this one in the lower right hand corner. We want number one variable statistics, okay? Even though we entered things into two different lists, we're not doing two variable stats. That's a whole different type of study. So once you hit number one or one variable stats, your screen should look like this. Just says one variable stats blank, okay? Do not, I repeat, do not hit enter yet. This is the most important thing we're going to do. Okay, your blinking cursor, I need you to hit second, which is in the upper left-hand corner, and then the 1. Once you hit second 1, you should see the L1 on your screen. And then we need a comma. The comma is right here just above the 7. Okay, then after the comma, we're going to hit the second button again, and then number 2. That should put the L2 on your screen. Okay, once you get the L2 on your screen, now you can hit enter, and we got a whole bunch of goodies. The first thing you see there is X bar. That's a fancy mathematical symbol for the mean or the average. All right, so the average score on this quiz was an 8.1. Then there's these two fancy things are your standard deviations. Those are kind of cool. We'll cover those tomorrow. Then N represents the number of data that was entered. There was 47 different students in the class. Here's the trick. If you see a 6 right there instead, that means you didn't get the L1 and the L2 on there. Okay, we did it wrong. All right, scroll down. We got just a few more goodies. Use your cursor, scroll down, and here's the good stuff. Okay, the minimum value, the lowest quiz score was a 5. The first quartile was a 7. The median, that's another name for second quartile. Don't forget that, second quartile. That was an 8, third quartile was a 9, and the maximum value is a 10. So the median is what they're ultimately asked for is 8. That's my answer. All I had to do is type it in the calculator. If they wanted the inner quartile range, I would do Q3 minus Q1, 9 minus 7 equals 2. All right, our next example, again, we got a lot of set of data. We asked the students in the class how many the number of uncles that they had. Kind of an interesting, weird question. But anyway, there was 2 different students who said they've got 0 uncles. There was 5 different students who said they had 1. There's 10 different students who had 4 uncles, okay? And here's what I want you guys to find on your own. I want you to find the median. I want you to find the mean, the median, and the mode. One of those we could do instantly without the calculator. And right there we could say that the mode was 4, because there was 10 different students who said they had 4 uncles. So 4 would be the correct answer there. Because if you listed out the data, you would write the number 4 10 different times, and so that's your most popular answer. Now, as far as the mean and the median, we're going to practice using our calculator. I want you to hit stat, edit, put all your number. I don't know if that should be really scores. That's probably a typo. That should be number of uncles. Okay, and then put your frequencies in L2. Remember, clear out the old numbers, or you can just type over them if you want. The calculator will allow you to do that. Then hit the stat button. This time, arrow over to the calc menu. Choose one variable stats. And then before you go any further, make sure you do L1 comma L2. And if you do that correctly, here's what you should see. So, let's see. We had a mean, or an average, of 3.17. Now they said, nearest hundredth, so I got to go, let's see, 2 decimals. So yeah, 3.17. Let's see, what else? 35. Make sure you have a 35. If you didn't have a 35 on your screen, that means you probably didn't get the L2, the L1 comma L2 typed in. What else do they have? Oh, we need median. Okay, that would be your second quartile right here of 4. The very last question of the night I'm going to leave up to you once again. We want to find the inner quartile range. Look back in your notes, see how we defined inner quartile range and how to find that. See if we can enter the data in. My hint to you here as I leave you to find your answer on your own is just use L1. Okay, just type all of this data into L1, and then when you hit your one variable stats, you actually don't have to type anything else. I mean, you could type L1 and then hit enter, or actually you don't even have to type in the L1. You can just hit enter right away, and then you'll see, if you scroll down, you'll get your quartiles, and you can find your inner quartile range. So basically, when we come around to check your notebook tomorrow, there's 3 different things I'm looking for you to have calculated on your own, and that'll be a good feedback for me to see how we're doing and how fast or slow we need to go on this chapter. Good luck.